Hello, this is the first part in the Making 2048 series for beginner programmers. For this episode, I'll be covering the concepts needed to make the game, and then in future episodes, I'll be walking through actually coding the game. And we're going to be using Python for the series. So if you have not installed Python, you can go to this link here. python.org/downloads and follow the setup. So if you're on Windows, you can just click this button, or if you're on Mac, you can go to this link. And yeah. After that, you need to open idle. So maybe you search for it or wherever you installed it. It should show up. And yeah, this is where we're going to be coding. So once you get to idle, the first thing I'll open is the shell. But to actually write our first program, we need to go to the top and click File, then New File. And so now this is where we can actually put our code. And when we're coding, we're trying to tell the computer to make or do something. So the first thing that we should try to do is something simple. So we can try to print something out. So have the computer show some text. Because in almost every application or game, the program will be displaying some text, so it is important to know how we can make it so that the computer will print out text on the screen. And so the way we can implement this is simply by typing print and then 2 parentheses, and then inside the parentheses put quotation marks, and then for now we can print hello. And so essentially the print statement, this right here, is telling the computer that we're trying to print something out, and then the parentheses are used to tell the computer what exactly we're trying to print out, and the quotation marks are essentially saying that we're trying to print out a phrase or a sentence, or any letters. So if we click run and then run module, it'll tell us that we need to save our program. So click OK. And then yeah, you can save it as whatever you want. So I'll call it hello. And so when we run, we'll see that it'll print out hello. So the next thing that we want to do is try and print this out 5 times. So let's say print hello, or you can just copy and paste this 5 times. So 1, 2, 3, 4. No, there's 5 in total. So yeah, if we click run again, we'll have to save it, of course, and you'll see that it prints out hello 5 times. So the next thing that we want to cover are variables. So this is kind of similar to variables in math. Basically, variables can be used to store information. So for example, if someone was coding a simple login or sign up feature, they would need a way to store all the usernames and passwords so that people can log in again. So in our program, we can use a variable to store the phrase hello, since that's some sort of information. So let's do that right now. Let us go back here. And instead of typing instead of printing hello 5 times at the very top, let's just say x is equal to, and then in quotation marks, hello. Essentially, this is x is like the name of our variable, and then equals, think of the equal sign as an assigning operator. So when the computer sees this line, it'll see like the equal sign, and it'll assign whatever is on the right, in our case the phrase hello, and store it in the variable on the left, which in our case is x. And yeah, it is important to know that the name of the variable can be anything. It doesn't have to be x or y. It can be anything. So for example, we can call it variable hello. But for now, I'll just keep it as x. And then instead of printing hello, we can simply print x, x. If we replace x with hello, you'll see that when we print it, it'll still print hello. So if I run it now, you'll see that it'll still print out hello 5 times, because x is simply the same thing as hello, so it'll print x. If we put quotation marks around the x and we run it, you'll see that it'll actually print out x, not hello. And that's because when we're trying to print out a variable, you never put the quotation marks. So yeah, that's just something to keep in mind. So we saw that in our variable we can store like text, so a word. In our case, we stored the phrase hello. And so that is what is called a string. So in our game, the types of variables that we're going to be using are strings, integers, and booleans. So strings are basically text, so any letters, words, phrases, or sentences surrounded by quotation marks. Integers are any numbers without a decimal point, and booleans are either a true or false. So, like we said, a variable can hold any of these. It doesn't have to be just a text. It doesn't have to be just a string. There are other types of variables, but for the game that we're going to be trying to make, these are the only ones that we'll need to know. A good thing about variables is that we can change them whenever we want. So that's something that's very useful, and it's one of the reasons why we may want to use a variable in our program. So if we go to our program, and in between the third and fourth print statements, let us change our variable to by instead. So if we do x is equal to by, and if we run it, you'll see that the last two print statements say by, and that's because now instead of x being hello, x is now by. So far we have covered how to make the computer print something, and we've also talked about variables, but right now the user can't really interact with the program. So like in different games, the user will always interact with the program by typing something or using their mouse. So that's what we're trying to get to. So for now, let us discuss getting input from the user. So if we go back to our program, and let us just delete what we have for now, and let's type input, and then in parentheses put 2 quotation marks and type enter a number. So this is basically what the computer will do when it sees this. It will print this out, so it'll print enter a number, and then it'll actually wait for the user to type something before doing anything else. So you'll see if we run this, you'll see it'll say enter a number. Now the computer's not doing anything else, and so if we actually enter a number, so let's say 5, you'll see the program ends. So if we run the program as we just did, we can see like the prompt, so it'll say enter a number, and where we can type something in, but nothing else happens after that. And the issue is that we're not doing anything after we ask the user to input something. So to change this, let us go back, and let's try to print out what the user enters. So for example, if the user enters hello, let's try to make the computer also print hello after that. And so a way we can do this is potentially by storing this input that the user enters in a variable. So let's say user entered is equal to input enter a number, and then if we print user entered, it should print back out what the user entered. So essentially, imagine that whatever the user enters replaces this input right here. So if the user enters like 5, this statement right here, this input, will be replaced by 5, and then user entered will equal 5, and so then I'll print out 5. So that's basically how this will work. So if we run, let's say enter a number, if we type in 5, it'll print back out 5. So we were successfully able to get what the user inputted and then use that information to do something different. Okay, so now that we know how to get input, we can try making a small rock, paper, scissors game by utilizing what we learned to make something that can actually be played. So for now, we can clear what we have, and so now the first thing that we'll want to cover the first thing that will have to happen in the game is asking the user to enter rock, paper, or scissors. And so as we discussed, to get input from the user, we can do input and then in parentheses enter rock, paper, or scissors. Now we'll also need to make it so that since the user is going to be playing against the computer will need to randomly choose one of the 3 elements randomly, so that each time, so if you run the program like 5 times, you don't want the computer to select paper all 5 times. You want it to randomly select either rock, paper, or scissors. And so the way we can do this is at the very top of our program, let's type from random import rand range. So this statement right here, I'll talk about it at a different time, so try and ignore it for now. But essentially, it'll just allow us to randomly select a number. So we'll be using the function randrange, so which will pick a random number from 0 to the number that we specify inside the parentheses, not including that number. So in our case, we want the computer to select either 0, 1, or 2, since there are 3 possibilities in the game. So we can do this by typing randrange is equal to 3. Or sorry, not randrange is equal to 3. Randrange parentheses 3. Now this will select a number from 0 to 2, since the number that you include inside the parentheses will not be included. So yeah, the computer will select a random number from 0 to 2, and we can save this inside a variable called computer chose. Computer chosen. And actually, we can call it computer choice since that's simpler. And also, we should also save the input that the user enters in a variable called user chosen, so that we'll know what the user selected. And then, yeah, it's good to save it in variables that we can later use it to compare with the computer's choice to see who won. So this is good. So the only issue is that what the computer selects is going to be a number from 0 to 2. However, the computer needs to choose rock, paper, or scissors, not a number. So we need to convert the number to rock, paper, or scissors. And to actually implement this in our code, we can use if statements. So if you look at the slideshow, the way we do this is by typing if, then parentheses, and then inside the parentheses, so essentially, if the computer's random number is 0, we need to convert it to rock. Else, if the computer's random number is 1, we need to convert it to paper. Or if the computer's random number is 2, we need to convert it to scissors. So to actually implement this in our code, we can use if statements, like I said. So you do this by typing if, then parentheses, and inside the parentheses, you put the condition. So similarly, there's elif, which is kind of like else if, which works in the same way, except it'll only be checked if the first condition was not true. Finally, there's else, which does not need to have a condition, and will only be run if the other 2 conditions were false. So for if and elif statements, the condition will either be true or false, which if you remember from when we talked about variables, basically means that the condition will be a Boolean. So if the condition is true, then the code inside the if block will run, and if not, then it won't be run. So this is probably kind of confusing right now since that's a lot of information, but when we implement this, it'll be more clear. So in our game, the condition, let's actually type out the different condition, or let's type out the different if statements. So let's do, so if, let's leave a condition for now, and then you have to press colon at the end, and then make sure you skip a few lines, and then cancel the indentation, and put elif, and then condition, and then put a colon at the end, and then skip a few lines, break the indentation, and then do else, and then colon. So in our first if statement, we're trying to see if the computer's choice is equal to 0. And we have the computer's choice stored in a variable called computer choice. So we can check if that variable is equal to 0. And the way we do this is by typing in this condition, type computer choice, so the variable is equal to 0. Now again, the variable can be called anything, so even if this was called x, and we used x instead of computer choice, it'll still work the same way. So we use two equal signs when we're trying to compare if two things are equal, because the single equal sign, which we used up here, is only used to assign data to variables, as we did previously. And that's why I emphasized that a single equal sign is like an assignment operator. So if you go to the line after the if statement, and make sure that we're indented, then we can change computer's choice to be rock. So do computer choice is equal to rock. And again, we use quotation marks, since if we don't have that, it'll assume that rock is a variable, which it's not. We want computer's choice to be the word rock. So now when the computer is running this code, it'll check this condition, computer choice is equal to 0. And if it is, then whatever is indented after this line, whatever's indented after this line will be run. And then after whatever's indented is run, the elif statement and the else statement will be skipped. So the computer won't even check if the condition is true in the elif statement. It'll just skip both of these. If the computer's choice is not equal to 0, then whatever's indented will be skipped, and the computer will check the elif statement and see if this condition right here is true. And if this condition is false in the elif statement, then no matter what, anything indented after the else statement will be run. Okay, so let's try and implement the elif and else blocks. So in our elif statement, our condition should be if the computer's choice is equal to 1. So yeah, we can do this by the same way. So do computer choice is equal to 1. Remember, it's having two equal sign. And yeah. So if that's true, then computer choice should now be paper. And now we know that whenever the else statement is being checked, the computer's choice has to be 2, since that's the only other possibility. Because if it isn't 0, and if it isn't 1, then the only remaining number is 2. So if that's the case, then we just want to change the computer choice to be scissors. And there we go. Okay, so we're almost done with this mini game. And at this point of the game, the user will have selected the choice, and the computer has randomly selected their choice as well. However, before we determine the winner, we should also print out the computer's choice so that the user will know why they either won, lost, or tied. So let's just go back to our program. And so after the user enters their choice and the computer randomly chooses their choice, we should print out what the computer selected. So type in, let's see, computer selected, and then put a colon, and then in our new line we can print out what the computer choice was. So type computer choice. And let's just run this for now to see if it works. So it'll ask enter rock, paper, scissors. So we type in rock, it says the computer selected scissors. And if we run it again, and this time you can type rock in again, it'll say computer selected scissors. Let's see. And let's just run again to make sure that the computer's choice is in fact random. Okay, yeah, so this time the computer selected rock, so we can see that the computer is selecting something at random, which is what we want. It's not always selecting scissors, which is good. So now to check to see who won, we can actually use more if, and else statements. The only difference is that now there are going to be more conditions, and we'll need to be checking more than one condition in each if statement. So for example, in one if statement, as you can see here, we'll need to check if the user's input is rock and the computer choice is paper. And if that's the case, then we want to print out that the user wins. And so the way we can check two conditions in one if statement is simply by putting an and in between the two conditions. So here's an example. And at this point, you can try and pause the video and try to implement these winning conditions by yourself. But I'll go over them. So let's see. So the first one we want to check if user chosen is equal to rock and computer choice is equal to paper. So if this is the case, then we're going to print user wins. Then we want to use an else if statement, since obviously this isn't the only possibility. So let's do if elif user chosen is equal to let's do rock again, and computer choice is equal to scissors. And then actually up here this should actually be computer wins, since obviously paper beats rock. And then down here in the elif statement, if the user selects rock and the computer selects scissors, then we should print user wins. And so there's going to be more conditions, so we can just copy and paste this at this point. Several times, and then change the conditions. So now let's check. Elif user chosen is equal to paper, and computer choice is equal to rock, in which case the user wins. And then if the user selects paper and the computer selects scissors, then the computer wins. Let's put 2 more of these. And now we need to check for scissors. So elif user chosen is equal to scissors, and computer choice is equal to rock, then computer wins. Finally, if user choice is scissors and computer choice is paper, then the user wins. So we've covered all the different cases. The only one that we haven't covered is if the user and the computer selects the same thing. So we can copy and paste a bunch more of these elif statements and do user chosen is equal to rock and computer choice is also equal to rock. However, we've already covered all the winning and losing scenarios, and we know that if none of these are true, then it has to be a tie. So if that's the case, then we can just simply put an else statement and type print there was a tie. And the reason we can just use this else statement is, like I said, we've already checked for all the winning scenarios, so the computer will check all of these, and if none of these are true, then there has to be a tie. So yeah, if none of these are true, then it's automatically a tie, and it'll print out there was a tie. So if we run this, we can save it actually. Oh yeah, and then, yeah, sorry, remember to put two equal signs when comparing if two things are equal. Let's try running again. Okay, enter rock, paper, scissors, so I'll enter scissors. And it says computer also selected scissors, and so there was a tie. So let's try it again. Let's try paper. And the computer selected scissors, so the computer wins. Let's try it again. We type in rock. The computer also selected rock, so there was a tie. Let's do rock again. There's another tie. And you'll see that, yeah, it works properly, so yeah, so this time the computer selected paper and we selected scissors, so we won. So yeah, so we were able to get that down, and yeah, so it works as we wanted to, and we made our first game. So we can see that we actually made a rock, paper, scissors game, which is pretty cool, and we've learned almost everything that we needed to know in order to make 2048. There are just a few more concepts that we need to know. So for now, let's just go back to our file and let us save it as rock, paper, scissors, just so that we have it down, saved. And then let's erase what we have. Since we already saved it, so we can always access it whenever we want. Or sorry, let's create our new file. And then, yeah, we can close that since we have it saved. Okay, so the next thing that we need to know are methods. And methods are very useful for organizing code. So for now, just follow along, and then as I cover it more and more, you'll see exactly how it works. So if we go to our file, and let's create our method by typing def, def, and then the name of the method, so I'll call it print hi. And then we always need two parentheses, and then a colon. And everything inside the method needs to be indented. So inside this method, let us say print hi. And then outside this method, so like after this statement, and make sure we're not indented, type print hi, and then two parentheses. And if we actually click run, or sorry, let's save it first, as methods. But yeah, if we run it, you'll see that it'll print out hi. So yeah, we'll see that the code inside the method will run if we have this right here, the name of the method, and then followed by two parentheses. It's very important to know that whatever's inside a method will never be run unless you call it by typing this statement outside of the method. So yeah, the computer actually never reads a method until you call it. So additionally, methods can return a variable. So if we go back to our file, and instead of our method printing hi, let's do this. Do return the phrase or the string hi. And now if we print hi, so you see that we're going to print the method out basically. And if we run it, it'll still print out hi. Oops. And yeah, so the way this works is when it reads this call statement, like the name of the method followed by two parentheses, it'll see that we're returning hi. So this call statement will be replaced by the string hi, and so if we run it, it'll just print out hi. So yeah, so returning it basically replaces the call statement. Okay, so if we go back, I'm going to create a new file because we're going to cover another topic. Cool. Okay, so the next concept we need to know are for loops. So for loops are very important because they allow us to better organize our code. So if, for example, if we wanted to do something repeatedly, it is very tedious to keep writing the same line of code over and over again, or even copy and pasting it. And so this is where for loops can be very useful. Yeah, so they help run chunks of code repeatedly. So if you go back to our file, I'll try and show an example. So to make a for loop, we type for, then x, for example, in range 0, 5, and then let's type out print hi. Okay, so what the computer is doing when it sees this is it'll see that it's a for loop, because there's the word for. Then it'll create a variable, and in our case, the variable will be called x. And yeah, so it'll create a variable called x, and the variable x will start out as 0, and then it'll print out hi. Now, instead of now going to the next line in our code, it'll actually loop back to loop back to here, and now x will increase by 1, and now x will be 1, and then it'll print this out again, hi, and then it'll loop back to this for statement, and x will increase by 1 again, so now x will be 2. And it'll keep on doing this until x reaches 5. And once x reaches 5, then the computer will skip whatever's indented, and then it'll go back down to like the next line of code. So for example, if we run this and save it as loops, for example, if you want, you'll see that it printed out high 5 times. And so I guess to show you a better way, let's just print out x and then print, I'll just print out x. So if we run this, it'll print out 0, 1, 2, 3, 4. So you'll see that we're printing out the variable actually, and what's happening is, x starts out as 0, and then it'll print out 0, then it'll loop back, and then x will be 1, so it'll print out 1, it'll loop back and become 2, so it'll print out 2, and then it'll keep going, and then after it reaches 5, once it reaches 5, it's hit the end of the range, and so it'll skip this print statement. So again, these concepts might be a bit more difficult for now, but when we get to the next episodes and start coding 2048, it'll become more clear. Another similar function is the while loop. So this is very similar to a for loop and an if statement. So similar to an if statement, whatever's inside the block, so whatever's indented after the statement, will only run if the condition in the parentheses is true. And similar to a for loop, the code inside the loop can be run repeatedly. So let's go back to our file, okay, let's make a while statement. Let's see. Okay, so let's first make a let's make a variable called counter and set it equal to 0. Now, in the condition for our while statement, let's have it so that while counter is less than 5. So whatever's going to happen inside this block will only run while counter is less than 5. So inside the block, let's print out high. Okay, so what the computer does when it sees this while loop is it'll check if the condition is true. So initially it is, right? Counter is equal to 0 and 0 is less than 5. So then the computer will print out high. Now the computer will loop back and now check again. Is counter less than 5? Which it is, because counter is still 0. And if it is, it'll print out high again. And it'll keep doing this until counter is no longer 5. And once it'll keep looping until counter is less than 5. And once counter is greater than 5 or equal to 5, it'll skip this print statement and then continue with the rest of the code, what's ever after it. So if you kind of see this, we have a problem in that counter never changes. So counter will always be 0 and 0 will always be less than 5. So our program will print high out like an infinite amount of times, and the computer will eventually crash. So we need to make sure that counter, let's say counter increases by 1 each time this is run. So after once counter is 0 and it prints it out, counter will now become 1, and then it'll be 1 is less than 5. So this will run several times. However, it will eventually stop since counter keeps getting bigger and bigger, so it'll eventually become greater than 5. So if we run this, you'll see that it printed out high 5 times because we increase counter by 1 each time. You'll see that if we increase counter by 3, it'll run a lot fewer times. It'll run like only twice. And that's because once at the start, counter is 0 and 0 is less than 5, so it'll print out high. And then counter will become 3. 3 is less than 5, so it'll print out high. But then it adds 3 to 3, so it'll become 6. 6 is no longer less than 5, so it'll skip this. So yeah, it's very essential that you make sure the condition will eventually become false. Okay, so let's go back actually, and I'm going to create another file for our next concept, which are arrays. So this is the next concept that we need to know. And arrays are very important because when we create a game like 2048, we'll be dealing with many numbers, and specifically 16, right? Since the game consists of a grid that's 4x4, so 60 numbers in total. And so instead of making 16 different variables that we'll have to all manage, we can instead have an array of 60 numbers. An array is basically like a list, so we'll have like a list of 16 numbers. Making an array is very similar to making a variable. We basically have the name of the array and have something assigned to it. So at the very bottom, you can see we can make something called practice array and set it or assign 2, 4, 8, 16, 32 to practice array. So let's actually code this up. So let's do practice array is equal to, and then the brackets tell the computer that we're making an array basically, and inside the brackets we can have all our data. So we want 2, 4, 8, 16, and 32 for now. Now, it's important to know that you have to separate each element by a comma, since that way the computer knows what the different elements are. So, so we have the name of the array and have the array assigned to it using the equal sign. So yeah. And we can also have, so the data inside an array doesn't have to be numbers. It can also be, for example, strings. So hi, bye, happy, right? It can be strings, booleans, or integers. It can be any of the variables. So in our case, yeah, let's set it back to 2, 4, 8, 16, and 32. So as I stated, this can be useful since we have 5 different numbers that are related in some way. So we don't actually have to use 5 different variables. A very important thing to know is that an array has indices. So an index is used to access one element in the array, which we will shortly do. So it's critical to know that the first element in the array has an index of 0, not 1. So if you look at this image in the top right, in our program we created an array with 2, 4, 8, 16, and 32, and it has a size of 5 since there's 5 elements. However, the index of the first element is 0, and the index of the last element is 4, not 5. And that's very important to know. So, to access an element in the array, we type the array name followed by 2 brackets. And inside the 2 brackets, as we can see here, we type the index of the element we want. So if we do that and try to access the element at index 0, so right here, practice array bracket 0, we'll get the number 2. So let's print out in our program the third element in the array. So we can do print, and then to get the third element in the array, we do practice array followed by 2 brackets. And then remember, the third element in the array has an index of 2, not 3. So we do 2 as our index. And if we run this and save it as arrays, you'll see that the number 8 is printed out, since that is the 8th, or sorry, that's the element with the index of 2. So we can also change elements in the array in a similar way as we do with variables. So, for example, in between this print statement, we can do practice array of 2 is equal to 9. And so if we run this, you'll see that it prints out 9 because we changed the elements at index 2 to be 9. It'll now print out 9 instead of 8. Let's see. Another useful function is the len function, which basically returns the length of the array. So this is very useful for going through all elements in the array. So I'll try to show you right now how it's useful. So let's use a for loop. So for x in range, and we'll start out at 0 since the first element in the array has an index of 0, and go to len of practice array, and then colon, and then indent, and let's print out practice array of x. Right, so x will go from 0 all the way to the length minus 1, right? Because in a for loop, this the last one is not included. The final bound isn't included when executing code. So if we run this, you'll see that it prints out 2, 4, 9, 16, and 32. Because so x will be 0, so printing out practice array of 0 will give 2, then x will become 1, so practice array of 1 is 4, so it'll print out 4. And I'll keep going until it reaches the length of the array, which is 5. However, once x reaches 5, it'll skip whatever's indented, right? Which is good because there obviously is no element within an index of 5 in the array. So if we actually try to print out, so actually I'll show you. So if we try to print something that's not, or that's has an index that's not in our array, you'll see that we'll get an error, list index out of range, because our array size is 5, which means the maximum index is 4. Okay, so we just need to cover one more topic, and that is 2D arrays. Now, 2D arrays are basically an array with each element inside that array being another array instead of a variable. So in a game like 2048, we deal with 16 numbers in a grid, meaning there are rows and columns. So from what we've learned, we could have one large array with all 16 numbers, or we could be more organized and make it more easier if we have 4 arrays, with each array representing either the column or the row. However, to make it even better, we could have a 2D array, since all 4 arrays would all be related to each other, right? Because obviously in the game you can move up, down, right, or left, so all the rows and columns interact with each other. And so let's see, let us try to make a 2D array. So I kind of put the syntax down here, but if we type it up, let's do array2 is equal to, so we have brackets, as we would have in a normal array. However, instead of each element being a number or a string or a boolean, it'll be another array. So let's have the first one be 1, 3, 5, or 7, and the second one being 2, 4, 6, and 8. Now, if we want to access an element in a 2D array, we type the name of the array, of the 2D array, so array2, then put 2 sets of brackets this time, since there are 2 arrays, so yeah. The first, the number inside the first bracket represents what element in the outer array we're trying to get, and the second number represents what element in the inner array we were trying to get. This is kind of complicated, so another way of thinking about it is the first number would represent the row. So if we have a 2D array like this, the first element will represent the row, and then the second number, designated by the second set of parentheses, will represent the column. So if we try to get, let's say, 5, we know that it's the first array, right? So the first number will be 0, and it's the third element in that array, which means it has an index of 2. So the second number will be 2. And let's print this out. So print. And if we run it, let's actually delete this where we had the example of an error. Let's run this again. Yeah, so it'll print out 5 at the very end, as we wanted it to. So yeah, that's where we're going to leave it off for this episode. It was pretty long, but we learned all the tools necessary and all the concepts to make the game 2048. So if you want to, you can try coding it by yourself, and use this video to review some of the concepts covered. However, in the next episode, we'll try to begin making the game together, and you can follow along. So you can leave any questions you have in the comment section, and I'll try to answer all of them. And make sure to subscribe and like the video, and I'll release the next episode soon. Goodbye.